So today we're doing binomial probability. Now this is a new concept that we have, and so we're going to talk about some basic things before we get into the binomial stuff. Okay, it says a random variable is a variable whose value is determined by the outcomes of a random event. So we have what are called discrete random variables. Now this means that it contains a countable number. So you can't have 1.5 people with blue eyes. You can either have a whole person or not a person. So it's a 1, 2, 3, 4 situation. So that means discrete. It's countable. Okay. Now, a continuous random variable can take on an uncountable or an infinite number of possible values over an interval. So how long it takes you to brush your teeth. It could be 10 seconds, it could be 1 minute and 30 seconds, it could be 1 minute and 32 seconds and 100ths of a second. So there's an unlimited number of possible times that could take you to brush your teeth. So that would be called a continuous random variable. So a probability distribution is a chart that gives each possible outcome and its corresponding probability. The sum of all the probabilities in a probability distribution must equal 1. If you'll remember from our very first day, we talked about how all total probabilities in a situation has to be a total of 1 or 100%. So a binomial experiment has n number of independent probabilities. Remember, n represents our total in the set. Has two possible outcomes. Either you're going to get what you want or you're not going to get what you want, success or failure. So that's why it's called a binomial probability, because you only have two possible outcomes, yes or no. Okay, but then you also have a probability for getting that outcome, and it must be the same for each trial. So it has to be a fair trial and always have the same probability. So when we're talking about probability here, this is always going to be with a replacement if we're doing something like that. Okay, so a binomial distribution shows the probabilities of the outcomes of a binomial experiment. So just like a probability distribution, but this one only has success and failures. Okay, a probability distribution is symmetrical if a vertical line can be drawn to divide the histogram into two parts that are relatively the same. Otherwise, the distribution is called skewed. So if you have histograms that look the same like this, you can draw a vertical line. That would be symmetric. If you have something like this, then that was going to be skewed. And this actually would be skewed left because the tail, it's longer to the left than it is to the right. So this would be a skewed situation. Okay, so the probability of getting k successes in n number of trials. So k just represents how many times we want it to happen, and n represents our number of trials. So this is our formula that we use. N combination choose k, the probability of success raised to the k power times 1 minus the probability of success raised to the n minus k, so the total minus successes. Okay, so remember, 1 minus p represents the not happening, so that would be our failures. And the n minus k would be the complement of the number of successes. So if we had 10 trials with 6 successes, that would be 4 not successes. Okay, now we can let the calculator do the work for us because our calculators are wonderful. So in this case, we are going to need to go into the second vars. So at this point, I'm going to pull up a calculator. So if we go into second and the vars key. It's next to the clear key. You'll see normal PDF, normal CDF. We don't want normal. We want the one that says by. So you're going to need to go down, and depending upon what calculator you have, it will either be 0 and A or A and B. So in mine, it's A and B. So it says Binom PDF and Binom CDF. This is where we're going to go to do these probabilities. Okay, so just to get you familiar with what it looks like, in mine, your number of trials is your N, your P is your probability of success, and your X value is how many successes. So we represent that with a K, and then you're going to put it in there. Now, if you don't have the newer version, remember it goes N probability K, NPK. So the binomial PDF, and we're looking at N probability, and then your K. So this is probability of success, and then this is your how many successes you want, and this is your total. So you have a 3-question true-false quiz. So 3 questions, that's my N. True-false. What's the probability of getting it correct if you have a true-false quiz? That's what we want to look for our P. Okay, so you don't study, so you have to guess. So our N in this situation is 3 because that's the total number of questions. The probability of success, well, since it's true-false, you either get it right or wrong, so that's a 50%, so that's a 0.5. So 0.5 chance of getting a success. So when we put this into the calculator, you're going to put in, go to second vars, select an A for binomial PDF. Remember, there's a PDF and a CDF. So you want to select the one that's PDF. 3 trials, so put a 3 in, comma, if you're doing it not with the list, the screenshot that gives you the list, you're going to put a comma after the 3, and then you put 0.5, comma, and you want 0 questions correct. So basically you got nothing right when you guessed. So if we do that, we want it to look like this. Okay, once you get this, you're going to hit enter. Okay, so on ours, our number of trials is 3. We have a 0.5 chance of success, and we are doing 0 successes. Okay, so I'm going to paste it. So again, your screen should look like this. If you did it without the pasting screen, you would just put commas. Remember, your comma is right above the 7. So 3, comma, 0.5, comma, 0. Hit enter, and it tells you that you have a 0.125% chance of getting it correct. So you will get a probability of 0.125. Now, if we typed in this equation like we had on the previous page, the formula from the previous page, which is what your calculator uses, you would get the same exact answer as if doing it with the binomial PDF. Now remember, one thing about the binomial PDF is this is for exactly one number of success. Okay, it's not a more than or less than. This is exactly 3 or 0 or 1 chance of getting them correct. Okay, so probability of getting 1 question correct. So go in and do the same thing. You do your binomial PDF, and you're going to put in 3 for the number of trials, 0.5, whoops, and then you're going to put a 1 in there instead of a 0. So you can do that second enter to get the entry in there again and just edit it to, instead of having to go through all of this, just edit the 0 into a 1. You're going to do the same thing for the binomial for a 2. So 3.52, and you're going to do the same for the binomial with the 3 questions correct. Okay. So looking at the 1 it gives you a 0.375. This will also give you a 0.375, and this gives you a 0.125. Okay, so hopefully you have done those and you see your answers are the same as mine. Okay, so the probability distribution, 0.125 for none correct, 0.375 and 0.375 for 1 and 2, and 0.125 for 3. Okay, you can kind of tell just from the numbers that this is going to be symmetric, because if you look at your values, they are exactly the same if you cross down through the middle of the graph. So drawing that vertical line like we talked about, this is a symmetric graph. Okay. Now, again, remember, exactly, if you want an exact number of successes, oops, then you're going to be doing the PDF. Okay, so if it says exact, you're looking at PDF. Now, it says in a standard deck of cards, we have 25% of them are hearts. So remember, you have hearts, you have diamonds, you have spades, and you have clubs. You're going to want to get familiar with these, and you should have a screenshot of a deck of cards from your first day of notes. Okay, so we have these. So 25% of them are hearts. Suppose you choose a card at random and notice it's a heart and replace it. So remember, replacement is important in this because it has to be the same probability every time. You conduct the experiment 5 times and make a table show the probability distribution for the number of hearts you could draw in the 5 trials. Okay, so how many trials? This is our N. That's going to be 5. We did it 5 times. How many possible outcomes do we have? Okay, well, you can have no hearts, 1 heart, 2 hearts, 3 hearts, 4 hearts, or 5 hearts. So there's 6 possible outcomes if you look at your probabilities. The probability of success, well, that's 1 out of 4 because only 1 of the suits are hearts, so it's 1 out of 4. The probability of failure is 3 out of 4 because there are 3 that are not hearts. So what is the probability of success? Well, that's 0.25. We already talked about that. Okay, it said, mention that up there in the top, 25% are hearts, so that's our probability of success. Okay, so since we can draw 0, 1, 2, 3, 4, or 5 hearts, we have 6 different possible outcomes. Okay. So, that is not what I was talking about. There are 4 different possible outcomes. At the back, there are 2. You either get a heart or you don't. But there are 6 different ways that can happen. We can get, in all of the trials, we can have no hearts, 1 heart, 2, 3, or 4. Sorry about that. You have 2 possible outcomes, yes or no, because we want to make sure this is a binomial experiment. So the possible outcomes has to be 2. My fault, apologize on that. Okay, so if we look at the 0 number of hearts, so we're going to type this into the calculator, and we're saying second vars. Do alpha, we can choose A, and it comes up to the binomial PDF. We have 5 trials with a 25% chance of success, and we want 0 hearts to show up. So if we paste that in there, we can get, okay, we're going to take it to 4 decimals, so it's 0.2373. So 0.2373. Okay, now this is what I was talking about, instead of having to go through that whole thing. If you go to second enter, you can go in and just scroll over here and change it to a 1. Because now we want 1 heart showing up. So again, 4 decimals, 3955. Okay, going back over here, doing this again, we have 2, so that's 2, 6, 3, and we're going to round that up to a 7, so 2, 6, 3, 7. Okay, so 0879. Oops. .0146. And last one, 5 hearts. Now that's probably going to be the least likely because only 25% chance of success. Okay, so it's got an E, -4. So remember, one space is already filled with the 9, so we add 3 zeros in front of that 9. And since this 7, we got to do a little bit of work. So we're looking at 0.00097. Now, because of that 7, that's going to round this up. So we add 1 to this, right there. So that gives us a 0. Carry a 1 over. So we're looking at 0.0010. Okay, so there's all of our possible. Now, obviously, since we rounded, it's not going to add up to exactly 1, but it should be close to 1. So if we added those up, it should be close to 1. If we did this exactly with the fractions, then we would have